So now we have switched, and it's important that you notice that we switched. We're not just talking about individual stocks like we were. Now we're talking about a portfolio of two stocks. And so they've chosen high tech and collections, and we've invested $50,000 in each of these companies. Now, this is a two stock portfolio, so this is like a terrible idea, but it's a good teaching point because the complication, well, the calculations are much less complicated if we look at just two stocks. So we're going to look at risk and return for a two stock portfolio. Once we get to more than just two stocks, the calculations get really, really long, and this is where you would want to use a computer program or Microsoft Excel, something that could handle a lot more data manipulation. So the expected return is simple. It's a weighted average. So it's simple like it was before when we had the probabilities. That was also like a weighted average. But here, the weights are going to be what percentage of my money do I have in each stock? And they said I had 50,000 in one and 50,000 in the other. So I have 50% invested in the first stock, which was high tech, and its expected return was 12.4%. And then I had 50% invested in collections, which its expected return was 1%. So if I say 50% times the first one plus 50% times the second one, I get an overall expected return of 6.7% for my two stock portfolio. Now, this is just one way that you could calculate an overall expected return for a portfolio. This is not the recommended way because this takes so long. What you would have to do is take the information from that table we had a while ago, with all the information about recession to all the way to the economic boom, get the expected returns in those different states and for both companies, high tech and collections, and calculate what the portfolio expected return would be for each one of these. And so they've already calculated the expected return on a portfolio of these two. So 0.5% times negative 27% plus 0.5% times 27% is going to equal 0 for this first one, and so on. So if you had each of these portfolio returns and then the probabilities, you could get an expected return by multiplying the probability for recession times the first portfolio return of 0%, and then the second probability of below average economy times 3%, which is this second portfolio return. And you just add up all of this and you get the same number, 6.7%. This is the long method, just another choice, not a really good choice, but it's another way you could do this problem. Sometimes some people like to know this. Now, it would be tempting for you to try to find the standard deviation of the portfolio as the weighted average of the standard deviations of the individual securities, but that would be terribly incorrect. It is necessary to use a different formula. The one for standard deviation that we used earlier applied to the two stock portfolio's returns. So the portfolio's standard deviation depends on two things. The first thing, each security's standard deviation, and the second thing, the correlation between the security's returns. The best way to approach the problem is to estimate the portfolio's risk and return in each state of the economy if you don't have the correlation information for the stocks, and then to estimate the standard deviation of the portfolio with this formula. Given the distribution of returns for the portfolio with those expected states, we can calculate the portfolio's standard deviation and coefficient of variation as shown here. So, and the reason why they went through all that, the mess on this slide right here, is so they could show this mess for standard deviation. So you have all of the probabilities are like the probabilities for the different states of the economy. So you take the first probability times the return in state 1 minus the expected return squared plus, and you keep doing this over and over till you get done. We have 5 different numbers that we would add up, take the square root, and we get the standard deviation of that portfolio of high tech and collections is 3.4%, which is a really small standard deviation. And if we wanted to know the coefficient of variation, we would take the standard deviation divided by the expected return, and we would get 0.51. So coefficient of variation is a relative measure. So you have to have other choices available to look at to say, should I choose this one with 0.51 or this other one that may be 0.4? So whatever the lowest number is for coefficient of variation, that would be the best risk return trade-off. But we just have this one example and we got 0.51. So you can see this is kind of a summary slide that the 3.4% standard deviation was lower than the standard deviations of either of the stocks that we were looking at, high tech versus collections. They both had high standard deviations. And even the 3.4% is lower than the weighted average of the two standard deviations, which isn't the correct thing to do. So why did we get this much lower standard deviation? Well, the reason why is that, remember, high tech, its returns moved positively with the economy, like directly with it. When the economy went up, its returns got better, whereas collections had a negative correlation with the economy. When the economy did better, it did more poorly. So those two stocks are negatively correlated with each other, they move in opposite directions based on the economy. And when you combine two things that are negatively correlated, you'll get a much lower standard deviation and risk reduction benefits.